So, this is part 2 of the 8.4 trig notes video. Hopefully you try to find angle C in both of these. And this one, if I was in class, I'd ask, what trig ratio are you going to use, sine, cosine, or tangent? And somebody would recognize you're going to use sine, probably say, why sine? And somebody said, well, you got the opposite side and the hypotenuse. Bingo, it's a sine ratio. Now, you probably wouldn't use these decimal values. You'd probably just type it right in your calculator, rad 10 divided by rad 11, and you'd be getting this decimal, 0.9534, et cetera, et cetera, et cetera, rounded off. And then on your calculators, you have this little inverse key, which allows you to find that angle measure, which should have been approximately 72. Same idea on the next one, but this would not be a sine ratio. You can see you don't have the opposite side. Instead, you have the adjacent and the hypotenuse, which would lead you to hopefully use a cosine ratio. And this is the type of work I don't want you to show on your paper for problems like this. I'm trying to give you an exemplar of how you show work. Some people say, well, I didn't show any work. I did it all on my calculator. Well, no, you did this. This is what you're doing. You're showing this work on yours. So anything you submit on Schoology would look something like this. And then, of course, you get that in decimal form, and you hit that inverse key, and C should have been 37 degrees in that case. I've got two more just like that, but I moved the location of C. Put C on the top of the triangle, and you know, it is a given. They're both right triangles.
We have sort of a problem.
And there are the two sets of side lengths you're going to use to get them. So again, good spot in the video to pause, see if you can find angle C for each one of those. So if I was in class, I'd have a conversation about this one, and I'd mention that this angle should be close to 45. And I'd say, anybody know why it should be close to 45? And of course, Matt right up front would volunteer and say, well, these two sides are approximately the same, so it's almost isosceles, which would almost make it a 45, 45, 90. And he'd be absolutely correct. And then Hannah would add to that, C is going to be a little bigger than 45, because 7's a little bigger than 6. So this angle got a little bit bigger, and this angle got a little bit smaller. So you should get a number smaller. Now you should be thinking about a tangent ratio, because you don't have the hypotenuse. You could find it, but that'd be a waste of time. Should be a tangent ratio, 7 over 6. And if you start messing with your calculator, that's the decimal you're trying to take the inverse of, tan inverse of, 1.1667, which gives you a 49-degree angle, which would make sense. It was a little bit bigger than 45. This one over here, if you accidentally found that one, is right around 41 degrees. You know, you could use the tangent ratio, but if you flipped this, you would have been thinking about the other angle on there. The last one, hopefully use the cosine ratio again. It's 0.9199, et cetera, et cetera, et cetera. Should have given you a 23-degree angle for that one. Hopefully those two both made sense. Hopefully you can see it on your bottom of your screen. Oops. Now these numbers I think are already on your paper for the second example at the bottom of the page. Trying to find all 6 parts of that triangle. We call that solving a right triangle. Round the answers to the nearest tenth. Angles, we often say round to the nearest degree. Good spot to pause if you haven't already done so. See if you can find those 3 remaining parts. That part, and the angle. This is a classic trig problem, so hopefully, you know, you found an easy way to find each one of these. If this was 40, the quickest way to find that one is to just realize they're complements. That one's got to be 50. So that's a quick answer. The other sides, you're going to have to use some sort of trig. So I'm just going to throw a variable up there just so you can see what I'm up to here. And if I was trying to find that one first without finding this one, probably use a tangent ratio, sorry. So the tangent of 40 is the W over 8, your opposite side over your adjacent side. Figure out whatever that decimal is. Clear the fraction by multiplying by 8. And again, this is how I would expect you to show your work. And you've got this fraction, you turn this into a decimal, and you're just doing 8 times that. It's not a ton of work, but it shows what you're thinking, how you're solving, and your final answer. Most of these are 3-step problems. And that's what it should look like if you round it properly to the nearest tenth. Another variable I threw up here, and you can call this C, I happen to call it X in this case, is your hypotenuse. I would recommend you don't try to use this rounded value with that exact value to find this value, because this is not exactly 6.7. If you kept this in your calculator with all the decimal places you see, and you squared it, and you add it to 64, that would work. You took the square root of that, that would work. That's an option. The other, which with Pythagorean theorem, the other option is just use these two sides. You got an adjacent side and a hypotenuse. You can set up a cosine ratio. The cosine of 40 is your adjacent side over your hypotenuse. This requires getting this decimal and dividing 8 by the decimal, which is a little bit trickier than doing the basic multiplication. It's just a different keystroke order in your calculator. Take 8 and divide it by whatever that decimal is. Take 8 and divide it by 0.766. And when you get your answer, it should make sense. If this is the hypotenuse, it's got to be bigger than 8. If you get something smaller than 8, you did something wrong. Obviously, this number should be larger. So it should be around 10.4. You can't see it on the screen right here, but it should be around 10.4, approximately, if you round to the nearest tenth. And of course, we said that other angle was 50 degrees. So those are the three remaining parts. Now flip the page over if you have the PDF that I put on Schoology, or make a sketch of this triangle here. You got triangle bug, and as you can see, it's a little bit peculiar looking compared to the other triangles on the other page. And I might say, what's peculiar about it in class? Somebody would very clearly recognize that it does not contain a right angle. So we're going to remedy that here in a minute. That's a 54-degree angle. I'm just going to put some variables here, and both of those are W, and the base is 20 units long. So I just want you to find the remaining parts of that triangle. It's a little trickier than the ones you've done on the front. It's got a couple steps in there. I'll be back in the next part, the next video, part 3.